And also that n1 squared over n1 over n2 squared gives us IA2 over 2 because of the resistance that is in parallel with the field. So those two are the same. So therefore, only half is going to set the flux up. And then we can say that flux 1 over flux 2 squared is IA2 flux 2 over IA1 flux 1. That brings us to IA2 over IA1 is flux 1 over flux 2 cubed. And then flux 1 is directly proportional to IA1. So therefore that's 20 amps. So IA2 over 20 is 20 over IA2, half of that cubed. And if we substitute that into our equation and we simplify, we find that IA2 is 33.64 amps. Now N1 over N2 is equal to IA2 over IA1. And if we calculate N2, we find that it is 713.524. I think this way it's easier than what is in Taraja. Then example 35 says the motor resistance is 1 ohm. Torque directly proportional to the square root of speed. The voltage is 220 and the motor current is 25 amps and N1 is 350 revs per minute and N2 is 500 revs per minute. Now what must be the secondary voltage? Yeah, question? Oh, come on. Right. So we say that IA1 over IA2 is N1 over N2. Therefore, IA1 over IA2 is 350 over 500. And therefore, IA2 will be 25 times 500 divided by 350. That gives us 35.714 amps. And then U1 is 220 minus 25 times 1, which gives us 195 volts. Then E2 is V2 minus 35.714 times 1. So now we need to determine V2. So E1 over E2 is N1 IA1 over N2 IA2. And therefore E2 is E1 N2 IA2 divided by N1 IA1. Now if you substitute the values there, you get 397.956 volts. And now E is equal to V minus IA. And if we transpose 35.714 volts, we get that V2 is 433.67 volts. Then question 36. We have a 200 volt, 20 amp, 1000 revs per minute with RA is 0.5 ohms and series resistance is 0.2 ohm. They put a resistance of 0.2 ohms in parallel with the field, and they say at half of the field current, the flux is 70% of that of the flux. 1. First step, always calculate E1, that is V minus IA RA. That is 200 minus 20 times 0.7, which is 186 volts. Then E1 over E2 is N1 flux 1 over flux 2. That gives us 200 minus 20. Now, that 0.2 in parallel with 0.2 gives you 0.1. So therefore, the resistance is 0.6, which gives us 188 volts. Then E1 over N2, E2 is N1 flux 1 over N2 flux 2, which is 0.7 flux 1. And then we calculate N2, and that is 1,444 revs per minute. So you see, all these problems, they use the same formulas. So look at number 37. It says there we have a 200 volt series motor taking 40 amp, and the speed is 700 revs per minute. And the second torque is 50% higher than the first torque, so T2 is 1.5 T1. And the armature resistance is 0.15 and the field resistance is 0.1. So torque directly proportional to the current. So T1 will be 40 squared and T2 is IA2 squared over 2. Oops. Where's the rest? There's it. So we have T1 over T2 is 2 times 40 squared divided by IA2 squared, and the torque is 1 over 1.5, and that gives us that the current is now 69.28. So E1 is 200 minus 40 times 0.25, that gives us 190 volts. And E2 is 200 minus 69 times 0.2. That gives us 186. And then E1 over E2 is N1 IA1 over N2 IA2. 190 divided by 186.144. 700 times 40. N2 over 69.282 divided by 2. And that brings us speed to 792 revs per minute. Sorry, I started off with 34, although there was 31 and 32 and 33 as well. So they say that the torque is directly proportional to the square of the speed. The T1 over T2 is N1 over N2 squared, which is IA1 squared over IA2 squared divided by 2. Remember, that's because the resistance is in parallel with the field, so the armature current is halved. So N1 over N2 is IA1 over IA2 over square root 3. We've taken the square root, né? And then IA2 is IA1 N2 times square root 2 over N1. E1 is equal to E2 because they've said nothing about the resistance, so we can ignore it. So that means that E1 is equal to E2. So N1 flux 1 is N2 flux 2, and N2 is IA2 over 2, which is N1 IA1. So IA2 is then 2 N1 IA1 divided by N2. Now if we substitute that, and then we can calculate N2, which is then the square root of 2 times 40 squared divided by square root 2. That gives us 713.53 revs per minute. Then example 32 says there, we've got a 2-pole machine. N1 is 707 revs per minute. The motor current is 100 amps and the voltage is 85. So now E1 okay, let's see. Those two now are in series. For the first one, now why did I say 0.1? Yeah, because there are two poles. It means there are two series windings, which is in series. That gives us 0.06 plus 0.04. That gives us 0.1. So it's 85 minus 100 times 0.1. That gives us 75 volts. Now they say, all right, we've got the two field coils in parallel. Torque remains the same, so IA2 is also 100 amps. And then flux 1, IA1 is flux 2, IA2. And therefore IA1 squared is equal to IA2 squared divided by 2. And therefore IA2 is 141.42 amps. And then E2 will be the two in parallel, 0.3. That gives us 0.015 and plus 0.04. The resistance then is 0.055 times 141, and that gives us 77.22 amps. And then again we say E1 over E2 is N1 flux 1 over N2 flux 2. So 75 divided by 77.22 is 707 times 100 divided by N2 divided by 141.42 divided by 2. And if we substitute and calculate for E1, okay, so then that is what we have. N2 IA2 is equal to N1 IA1, sorry. And then IA2 is equal to 2N1 IA over 2 N2. We simplify that, and then we get that the speed is 713.53 revs per minute. Any question there? All right. Then example 32. Also a 2-pole machine, 707 revs per minute, motor current 100 amps. Oh man, that's the bloody same one. All right, then we found that the speed is 1029 revs per minute. Then they say E2 is now 77.22, N2 is 1029 revs per minute. Now we want to know the resistance to be added so that the speed becomes 707 again. So E2 over E3 is N2 IA2 over N3 IA3, which is 77.22 divided by 85 minus 141.42 times R is 1029 times 141 over 42. Those two are the same, so we can ignore that. So then it's 77.22 divided by 85.14142 times R over is equal to 1029 over 707. That gives us 53 is equal to 25 minus 141.42. If we solve for R, we find that it's 0.226. And the external resistance to be added then will be 0.226 minus 0.04 minus 0.15. And therefore, the external resistance is 0.171 ohms. Right, example 33. It says there, we have 240 volt, motor current 40 amps, speed is 1500, and the resistance of the motor is 0.3 ohms. The torque remains constant, and N2 is 1000 revs per minute. They want us to calculate the resistance that will give maximum torque at starting. So therefore 40 will be 240 divided by R plus 0.03. And that calculates R is 6 ohms, and the external resistance is 5.7 ohm. Then again, we have E1 over E2 is N1 IA1 over N2 IA2. So there we have E1 is 240 minus 40 times 0.3 gives us 228 volts. E2 will now be 240 minus 40 times R plus 0.03. And E1 over E2 is N1 over N2. And that's 228 over 240 minus 40 times R plus 0.03 is equal to 1500 over 1000. If we calculate R2, we find that it's 2.2 ohms, and therefore the external resistance is 1.9 ohms. Okay, are there any questions? You can see the same trend goes for all of these problems. You must just use your formulas that are given. All right, then the next chapter is going to be no, where is that now? Part 2. I see. Now I can't remember what chapter it was. Not that one. Let's also simplify alternators, synchronous motor, testing. Hey man, where is it now? Induction. Oi, all right, that will be the chapter on AC machine speed control. Well, maybe it's in book number 3. Oi, was it? Chapter 46. Electronic control of AC motors. There's the classes of electronic AC drives. We have a static frequency changers, variable voltage controllers, rectifier inverter with self-commutation. So those are the drawings. And variable frequency. and then variable voltage control with the drawings. That is just the theory on this chapter. So you can go through that. Chopper control, yeah. All right, you can just go up to chopper control. WRIM is a wound rotor induction motor. Right, now let's discuss the CAS test. That will be similar to these questions that we've covered. Now, what I want you to do is to fold your page in half and write on each section then like that. Let me just get rid of this. So there you've got each half of the page. So you're going to write your title or your student number and your surname on each section. Then you're going to write this side and that side. So that you save paper and save my printer. And as this is exam instruction, if you are not doing it like this, I'm not going to mark it. You understand that? Anyone? Dimple?
Yes, sir.
Zile, you understand?
Can you please repeat what you just said?
I said you must take your paper and fold it in half, like that. And then you write on each side, so that you save my printer and my paper, if I have to print it. And then on top, you write your student number and your surname and initials on each page. Okay?
Oh, okay, say thanks.
And then you've got hour and a half, 90 minutes to write. And then after that, you've got 15 minutes to email me your paper. And you are going to email it to jolr@vut.ac.za. I'll put it on the group. And I said the test was on the
The 4th.
So you write at 1800. I'll put the test on here, sorry, and on the email, on the group. Any questions there? No questions.
No, sir.
So the paper will be 90 minutes and 50 marks. And mostly calculations. Theory will come from the chapter on AC motor control. Okay, guys, if there are no more questions, remember you can WhatsApp me or email me and I will answer you quickly as possible. Right, then I see you on Monday, no, Tuesday night. No? Enjoy the weekend.